Greetings. Welcome to the lecture number 2 of vector analysis. In the previous lesson, we have learnt about basic vector algebra, and their product. But in this lesson, we will basically start about the vector calculus. Here we will learn about vector differential operator, and next lesson we will learn about vector integral operator. But in that lesson, vector differential operator, we have to learn three things about the differential operator. The first one is divert gradient, then divergence, and then curl. Basically, these three things are important for us in the differential of vector and vector calculus as well. The first we will learn about the gradient. A gradient is mathematically defined is in that form: grad phi is equal to d phi dx I cap, d phi dy j cap, d phi dz k cap. That's also can be written as d of dx I cap plus d dy j cap plus dz k cap of phi. This phi is a scalar field, and these terms can be written as the nabla operator. This operator called nabla operator or del operator. Also, to solve some of the problem, also we need three very important thing to know: that how a normal vector is determined, that a normal vector is simply the gradient of that vector is that normal of the vector. We'll learn it in the physical interpretation part. The unit vector is basically the vector unit normal vector is basically the unit vector of that normal vector. We know how to determine the unit vector. In our previous lesson we have learned this, that del phi by mod of del phi, and the directional derivative in a direction can be written as that grad phi and dot product of the unit vector of this a. Now let's take an example and solve a problem. For a mathematical physics part, how much problem you solve, that will more give you clarity of the concept. Okay, now find the gradient of r to the power n. To find this, first thing we have to understand that we need to take this vector r as xi cap plus yj cap plus zk cap. If we have this, then what will be r square? R square is equal to r dot r, that can be written as x square plus y square plus z square. This is why, because the dot product of I will be vanish, there only that term will be exist, and x and y, these will be not communicate because that is dot product I dot j is 0. Okay, now we have to find that gradient of this term r to the power n. Gradient of this term is equal to nabla operator del x I cap plus del y j cap plus del z k cap r to the power n. Now take this r to the power n into it, then del r n r to the power n by del x I cap, del r to the power n del y j cap, del r to the power n del z k cap. So we have this. Now we can know the what will be the derivative of this term, that n r to the power n minus 1. Now this is not exactly that term is only not dependent on that term, so we have to write down that dr dx I cap, dr dy j cap, and dr dz k cap, and n r to the power n minus 1 we have. Okay, now we have to find these values only, otherwise we have clear our goals as much as possible. Okay, now if we already have r square is equal to this. Now what if we differentiate the both side of this, we will get del r del x. Actually we will 2 del r del x, 2r del x is equal to x by 2 del x, if with respect to x we do in 2 dx, and so that del r del x should can be written as x by root over this. Okay, now for r, if r square is that, then this can be written as x by r. The same way we can write del r by del y is equal to y by r, and del r by del z is equal to z by r. So gradient of r to the power n can be written as n r to the power n minus 1 x by r I cap, y by r z cap, z by k r k cap. This is our known things, that vector r by r, and what we called it the unit vector. So the final answer is n r to the power n minus 1 into unit vector of r. Let's solve another problem uh, and end with this thing. If a phi xyz is that so an scalar function phi is can written by as 3x square y minus y cube z. So find the gradient of phi at this point. This is also a very cool problem. We have the first thing is we have to find the gradient grad phi. That grad phi can be written as the nabla operator uh, into this 3x square y minus this. Okay, now differentiate it with respect to x. What will get, that is 6xy, and that value will be not, we should not consider that value because we are doing it with respect to x and there is no x term, so for this it will be 0. And then find this term with j term, that 3x square minus 3y square z square. For z term, j cap term we have this, and for this term we have this term is useless for us as we are doing with respect to z. So for this term we will get 2 y cube z. Okay, k cap. So at the minus point, we so till now we have find the grad phi. Now we have to find at this point. How will we simply put the value of x, y and z in this term? Do it. 6 into 1 minus 2 I cap plus it's z cap j cap plus n. So we get minus 12 I cap minus 9 j cap minus 16 k cap. Okay, so grad phi at this point is this. Simple. uh, for your convenience we have attached your study material in description box. Thank you.